Welcome to today's video where we're going to look at how to divide polynomials. The unit starts out where I'm going to review a process that many of you would have come across in your schooling days, where we look at what's called long division. So you remember seeing this type of thing at some point where you're going to take the number 785 and I want to divide by 3. So I'm just going to review with you how that process went. And the reason I'm doing this is because I'm going to show you how to do this with polynomials, and it's pretty much the same type of process. So we got to make sure we understand how this all works. So this is just to refresh your memory. The way it started out is you looked and you tried to find how many times would 3 go evenly into 7, and it would be twice. So you'd put a 2 there, and then you'd take the 2, you'd multiply it by 3, put the answer here, which was 6, and then you subtract. 7 take away 6 is 1. And this shouldn't go evenly into this, otherwise you didn't pick a big enough number here. Bring down the next number, so bring down the 8, and now you say how many times will 3 go into 18, and the answer is 6. Giving me 3 times 6 is 18. So this time they subtract to give me 0. I'm not going to put anything, well, I'll put the 0 there. Bring down that next digit. So the 5 comes down. So now I've got a 5. 3 goes into 5 only once, giving me a 3. 5 subtract 3 is 2. So what this means is that 3 goes evenly into 785 261 times with what we call a remainder of 2. All right, now I'm going to use this type of process and show you how to do long division of polynomials. All right, so if I wanted to take this is a polynomial, and I want to divide it by x plus 2. Let me just backtrack for a second. So a polynomial, just to refresh your memory from grade 9 math, I guess it would be now, polynomials are multiple termed expressions, or they could be single termed expressions, I guess, where there are variables. All exponents are positive integers, so there's no fractions, there's no decimal exponents, no negative exponents, all positive exponents. A series of terms added and subtracted would be considered polynomial. So this would be a binomial, two-termed expression. This would be, once it goes, so there's binomial for 1, 2 terms is one is monomial, 2 terms is binomial, 3 terms was trinomial, and once you go beyond 3 terms, they just lump them all together and call them polynomials. Sometimes you might have heard them called many-termed expressions. Now, what you're dividing into is referred to as the dividend. What you're dividing by is called the divisor. And the answer you get at the top is referred to as the quotient. Now we're going to write it out in the long division format like we looked at earlier. And we're going to go through and I'm going to show you how you do this with polynomials. Now, here, even though there's 2 terms here, you only look at the first one only. And you say, how many times could I multiply x by some other power of x to get x to the 3rd? Well, the answer is x squared. And you're going to put x squared up here. Now, if you remember on the long division, when you put a number up here, when you were trying to figure out how many times, like it was 3 went into whatever number we did in the last one, we put the answer there. Remember, we multiplied them together and we put the answer underneath. It's the exact same. I'm going to take this expression and multiply it by this. X squared times x plus 2 is x to the 3rd plus 2x squared. And then you're going to subtract these. In long division of polynomials, these two should always subtract each other. Now make sure you realize we're subtracting, we're not dividing. X to the 3rd subtract x to the 3rd is 0. X squared subtract 2x squared is a negative 1x squared. If there's 2 terms here, you're going to want 2 terms here. So we're going to, just like we did before, bring down the next term, including the sign in front of it. So this would now become subtract 3x. And now you start the process over again. What would I have to multiply just the first term, x by, to get negative 1x squared? Well, I would have to multiply by a negative x. Whatever you put here, including the sign, you multiply it by this, the divisor. So negative x times x is negative x squared. As I mentioned in the first one, these two should always eliminate each other. Negative x times a positive 2 is a negative 2x. Subtract. Now you have to, I find one of the biggest mistakes students make here is with integers. They don't pay attention to signs and subtracting negatives, adding negatives, all that interesting stuff. So when you take a negative 1x squared and you take away a negative x squared, you get 0. Now watch here. Negative 3x, subtract a negative 2x. I'll write it out over here. This is what, now you're going to do this in your head, but recall your work from integers. When you get the two negatives like this, it really means to add. So when I go negative 3x, subtract a negative 2x, I'm going to get negative 1x. Bring down your next term. Subtract 1. What do I multiply x by to get negative x? It would just be negative 1. Negative 1 times x, negative x. Negative 1 times 2, negative 2. Subtract to give me 0. That's what we said always happens. Negative 1, subtract a negative 2, that's a positive 1. When you're doing long division of polynomials, down here, you know you're finished when what's called the degree, it might be a new term for some of you, not degree as in degrees of an angle, but degree as in this polynomial would be what's considered a degree 3. And the reason it's called degree 3 is because the highest exponent is what you use to determine the degree of a polynomial. So this would be a third degree polynomial. This would only be a first degree polynomial because the highest exponent anywhere in it is a 1. So the rule is, down here, your remainder, once you get to a degree that's lower than the divisor, then you know that you are at the remainder. Now, sometimes students will say, well, it's just when you get to the number. It is in the beginning of these easy ones. They're not all going to be this easy. You're going to eventually divide by x squareds and x to the fifths. If you're dividing by an x to the fifth, for example, here, your remainder can have exponents in it. So your remainder is not always going to be just a number like it is with long division involving numbers. If you're dividing by a degree 1 polynomial like this one, yes, your remainder is going to be just a number. However, if you're dividing by something higher than degree 1, as soon as this is a lower degree than the divisor, so lower degree, lower degree than the divisor. All right, so let's try a couple of these now. Again, you may want to watch another one before you try your own, but I have quite a few of them written out here for us to practice. All right, so one thing that didn't happen in either of these examples, but you're going to have to watch for eventually, is these, both the divisor and the dividend, what you're dividing into, have to be in what's called descending order of power. What that means is they have to be in order from highest to lowest exponent. If they are not, you'd have to rewrite it so that they are. So for example, if this 2x cubed had been stuck over here at the end and the 10 was at the front, you couldn't write it that way under your division symbol. You have to go highest, so 3, see the exponents, x to the 3, x to the 2, x to the 1, x to the 0. Those are in descending order of power. X to the 1, x to the 0, those are in descending order of power. So again, both the divisor, I can't have that there, both the divisor here and the dividend have to be in descending order of powers. We'll see some later where they're not, and we rearrange it first. Okay, so here we go. I'll go a little bit quicker now as we kind of start to get the hang of this. What would I have to multiply the first term by, x, to get 2x cubed? The answer would be 2x. 2x times x, 2x cubed. 2x times a positive 3 is a positive 6x. Sorry, that's x squared, not x. X squared times x to the 1, you add the exponents, that would give you x cubed. There, that's better. All right, subtract, that gives me 0. Negative 6x squared, subtract 6x squared. So sometimes students say, oh, they're 0. Think about what we're saying now. Negative 6x squared, subtract 6x squared. That's negative 12x squared. Bring down your next term, so it's a plus x. What do I have to multiply x by to get negative 12x squared? The answer would be negative 12x. Multiply that by both of these, you get negative 12x squared. Negative 12x times 3 is negative 36x. Subtract 0. X, take away negative 36x is 37x. Bring down your next one. What do I have to multiply x by to get 37x? It's a positive 37. 37x. 37 times 3 is 111. 0. 10 subtract 111 is negative 101. This is the remainder. Now, just jumping back here for a second, just from your work with division. So if you get a remainder here, that means that 3 doesn't go evenly into 785. Where this is all leading in a day or so is we're going to factor polynomials that are not fitting the mold of any of our factoring strategies we've learned. If you get a remainder, that tells you this is not a factor. Now, if I had done this out and got 0 here, no remainder, that would tell me 3 goes evenly into 785, which would make 3 a factor of this. So that's just in the back of your head thinking, what the heck are you showing me this crazy stuff? There is a method to this madness. It is to help us be able to factor higher degree polynomials. So I can see here, for example, because there is a remainder, x plus 3 is not one of the factors of this polynomial because it didn't go evenly. Okay. All right, this next example, there's one little thing over here that makes it a little different than the first. So the first two will be what I call kind of your textbook introductory questions. Everything was perfect. Everything lined up. If I just back up for a second, all the powers lined up beautifully, and it's pretty straightforward once you get the gist of how it's going. So that's kind of what those first examples are for. These next ones are going to get a little bit more challenging. Don't get overwhelmed. Just kind of bear with me here. If you notice here, this one goes x to the 4th. It doesn't have an x to the 3rd term. It has an x squared term. It doesn't have an x to the 1st term, and then it has a 2. So let's see what happens when we do our division. We don't change anything, but things might not line up as perfectly as they did before. All right, so we start out with looking at the x and looking at the x to the 4th. I'd have to multiply by x to the 3rd. Multiply both of these by x to the 3rd, and I will get x to the 4th, take away x to the 3rd. All right, so right away now, here you're going to see that things are a little bit different. These two, they wipe out. They should always eliminate each other. X to the 4th, subtract x to the 4th is 0. But with polynomials, if I say to you, what's x squared, take away 5x to the 3rd, well, there's nothing you can do because these are not like terms. You can only add and subtract when the variable parts, right, the x's, are the same. These are not. So that's what happens here. Well, and you always want to go down in descending order. So I'm doing the x to the 4th and they're eliminated. So the next exponent that I'm concerned with is x to the 3rd in the chain, but there is none here. In your head then you have to say there is, some students even like to actually physically write it in. You shouldn't need to. Just think, there are no x to the thirds in this top polynomial, which means I'm going to have 0x to the 3, take away a negative x to the 3. That's going to give me a positive x to the 3. Okay, I'll show you that again. There's 0x to the thirds up here. Subtract a negative x to the 3. I'm going to get positive x to the 3. So we've dealt with x to the thirds. Then you say, well, what's the next exponent going in descending order? Well, it'll be x squared. There's negative 3x squareds here in the top. Take away any x squareds that are underneath it. Well, right now I don't have any, so it's negative 3x squared. Take away 0x squared, which would be negative 3x squared. All right, so you can see how things aren't lining up perfectly like they did in the first two examples, but that's okay. We still just keep on going here. Start over again. X, I want to get x to the third, so I'd have to multiply that by a positive x squared. X squared multiplied by x squared, x to the third. Remember, these two should always end up identical. X squared times a negative 1 is a negative x squared. Well, the good news is these line up better this time, so it's x to the third minus x to the third, 0. Negative 3x squared, subtract a negative x squared. That really is the same as a plus because it's subtract a negative. That's going to give me negative 2x squared. There's no x term here, so I'm just going to bring down the next term that's up here, because if there's two terms here, you're going to want two terms here. So I'm going to bring that plus 2 all the way down. And here we go again. X, I'd have to multiply by negative 2x. Negative 2x times x. There's my negative 2x squared to eliminate those two. Negative 2x multiplied by a negative 1 is a plus 2x. Now remember, always keep going down the exponents in descending order. The x squareds wipe each other out. So the next exponent I'm worried about is the x. So there's no x's anywhere else in the polynomial. Right up here, there's no x's above, which means there's 0 x's. So you're always subtracting this line. So it's 0 x's up above, take away 2x. That's going to give me negative 2x. Now the number 2, we've already brought that down from way up at the top. It's going to subtract any numbers below. Well, there are none. So 2 take away 0 would give you a plus 2. All right. So we're still not at a degree. This is degree 1. This is degree 1, which means I can keep going. One more time. I'm going to multiply by negative 2. Negative 2 multiplied by x is negative 2x. Switch this to the other side. Is negative 2x. Oops. Negative 2x. And then negative 2 multiply, so negative 2, which is up here, multiplied by your negative 1 is going to give me a plus 2. There's the first time this has happened. There is no remainder. You know what that tells me? Again, this is kind of a foreshadowing to where we're going with this eventually. I know that x take away 1 is a factor of that polynomial. It's one of the factors of the dividend. And the reason I know that, is because there was no remainder when I divided it. It went evenly. Alrighty, let's try it. So this one, I'm double checking here. They're still in descending order. Now this one should work pretty nicely because everything's there. X to the 4, 3, 2, 1. So we should be good. We shouldn't run into too many snags on this one. You should be able to do it pretty quickly. Alright, so it's going to be negative 2x cubed multiplied by x. There's my negative 2x to the 4th. 4 times negative 2 is negative 8. X to the 3rd. Subtract. 9x cubed. Bring down your next one. That means I'd have to multiply by negative 9x squared. Multiply that by your, not negative, be positive. 9x squared times x would give me 9x cubed. 9x squared times 4 would give me plus 36x squared. Subtract, negative 39x squared. Bring down your next one. Now, my numbers are going to get big here on me. Let's see, negative 39x. That'll give me negative 39x squared. 39 times 4, negative 156x. Subtract, forgot my x. Subtract will give me 1, so it's positive 5, take away a negative 156. So that's going to become positive 161x. Bring down your next term, which is a plus 4. So I'm going to multiply by 161. 161 times x is 161x, and I got to multiply 161 by 4. So 161x, 4 times 160 would be 644. 0, 4, take away 644 is a negative 640. Now, the worst thing about this process is any little sign error anywhere up above here is going to make everything below it normally go off the rails on you. You're going to get it wrong. So you got to pay really, really close attention to your signs. Now, it's always nice when I'm doing this in front of the audience in class because you guys can find any mistakes for me that I may screw up on the way. Unfortunately, here in the video, I may mess up some of these by a sign error or something, and I apologize in advance. All right, so that one didn't go evenly. Now, here's one where we're dividing by, notice this time, so everyone so far we've only been dividing by x to the first. But I think we're getting our heads wrapped around how this works now. Let's write this one out. Make sure these are descending order. 2x to the third, take away x squared, plus 5x minus 3. Nothing changes. Here we go. X squared, to get 2x cubed, I'd have to multiply by 2x. 2x times x squared is 2x cubed. 2x times negative 1 is negative 2x. All right, now here, I wouldn't know what's going on. This should be to the third. There we go. These two subtract. That's x to the third. So my next exponent I'm worried about is the x squared. So this time it's up here. So it's negative x squared. Subtract any x squared you see underneath here. There are none. So negative x squared, take away 0x squared is negative x squared. So like the two examples ago, they're not all lined up because the x is here and the other x is here. So now it's going to be 5x, take away a negative 2x. 5x take away a negative 2x. That's going to be plus 7x. For x squared to give me negative x squared, I'd have to multiply by negative 1. That would give me negative x squared. And then negative 1 multiplied by negative 1. There's your plus 1. All right, so let's do x squareds eliminate. They're gone. Next exponent is x to the 1. There's 7x here. I subtract any x's that are underneath it. There are none. So 7x take away 0 is 7x. This number 1, there's a number way up top here that I got to subtract. So it's going to be negative 3, subtract 1, negative 4. So look at this time. As I said earlier, your remainder can actually have a variable in it. So how do you know that's the remainder? Remember I referred to the term degree. This is degree 1 because the highest exponent is a 1. This was degree 2. And I said that when the degree down here is lower than the degree you're dividing by, your divisor, then you know you're at your remainder. Now what this means is also, if you kind of put the connection of these all together, like for example, let me just go to a blank page for a sec. If I said to you 19, divide that by 4, and you said, well, it goes 4, and you get 16, 19, take away 6, you get 3. That's it. This means, though, that 4 times 4 is 16, right? Plus the remainder will give you what you were dividing into. So this, the quotient, multiplied by the dividend, 4 times, by the divisor, sorry, 4 times 4 is 16. Add the remainder, you will get this. So I've seen sometimes in a question where they take and they erase this. If they tell you this, this, and this, you should be able to figure out what that number was. So for example, if I went, I don't know, 3, I put here 11, and I said the remainder was 2. And I said, what did I have to divide into for this to happen? Well, it's easy to figure out. I just say, well, it must have been 3 multiplied by 11 plus 2. It must have been a 35. Now, why am I showing you that? Well, because here, I should be able to, if I was to erase this, which we will probably do later on in some example, make you figure out this, you should be able to tell me that x squared minus 1, if I multiply it by the number or the expression on top, and then I add the remainder, which was another algebraic expression, 7x minus 4, I get this. Because of that connection between quotient, divisor, and remainder. The quotient multiplied by the divisor plus the remainder always gives you the dividend, what you were dividing into. So here, we will do it later on, but you'd have to expand this all out, collect like terms, and you have to trust me on it that you would get that polynomial. Okay, so let's take this one. Oh, I like this. This is good. So this is kind of, you really got to know your stuff to get this one. So let's take x to the third minus 1, and we're going to divide it into. Do you notice here how I go 5, and then it goes 3, 4, 2? So you got to get these in order. So it's going to be x to the 5th plus x to the 4th, subtract 3x to the 3rd, subtract x squared, and then plus 1. So that's descending order. Here we go. X to the 3rd, I want to get x to the 5th. So I got to multiply by x squared. There's my x to the 5th minus x squared. Now things are way out of whack here. So those are going to eliminate. X to the 4th is next. So x to the 4th is going to come down to give me x to the 4th. The next, remember, you always keep going down the exponent list. So the next exponent we should deal with is the x to the 3rd. So it's going to be negative 3x to the 3rd. Take away any x to the 3rds that are underneath here. It's going to, there's none, so it's negative 3x to the 3rd. Now, I know that we're only supposed to have 2 here, but sometimes we'll forget about this one because this x squared and this x squared down here have to subtract. Now, luckily in this question, negative x squared minus a minus x squared, they are going to eliminate each other anyway. So that's going to be 0. But sometimes if I was doing this one, I might put that extra 3rd term out here and just work with the first 2 just so I didn't forget about it. However, you can just keep looking up here too if you want. All right, so we got to multiply by a plus x. That's x to the, what am I got going on here? X to the 4, not 3. X cubed times x to the 1, there's my x to the 4. X times minus 1, that's minus x. Now let's not lose track of stuff here. So those are gone. We do our x cubes next. So negative 3x to the 3, subtract any x cubes underneath here, which there are none. So it's going to be negative 3x to the 3. Next exponent for us to manage is the squareds. So I'd say, well, I got negative x squared here. I was supposed to subtract this one here, but I already had 2 powers that were above that one, so I never got to deal with it yet. Negative x squared, subtract a negative x squared is 0. So those are gone. Well, the next concern I have then is x to the 1st. Well, there's no x to the 1st here. This is in the subtract line, so it's no 0x to the 1, subtract a negative x, which is going to then give me a plus 2x, because it's not plus 2x plus 1x. right? 0, there's no x's here, so 0x, subtract a negative x will just give you a plus x. Negative 3x cubed, and I've got an x cubed here, so it's going to be negative 3. There's your negative 3x cubed. Negative 3 times a negative 1. That's a plus 3. My x's, so it's x, subtract any x's that are underneath it. There are none. Now our numbers. So remember, this is the subtract line. You're subtracting this line from any powers the same as these up above. I've got 1, subtract 3. That's minus 2. So this is the remainder. Telling me that if I was to multiply this trinomial by this binomial and then add that algebraic expression, I would get this polynomial. All right, so that's kind of an interesting one of long division. And that's just, I mean, to get that one right, you've got to really know your stuff. So we're getting to the point here now where you'd want to be stopping these and trying them on your own and see how you make out. Here's my solution. So x to the 4th, x to the 7th. I'm going to multiply by x to the 3. That'll give me x to the 7 plus 2x cubed. So those will eliminate. The next exponent going down the list would be x to the 6th, but there's none there, so don't worry about that. They're gone. X to the 5th minus any x to the 5ths below it. There are none. X to the 4 would be next, but there are none. X to the 3 would be the next, but there are none, but there is one here. So it's 0x to the 3. Take away, that's a 0. This 2x cubed that's below it. So that'll give me, subtract 2x cubed. X to the 4th, I'd have to multiply by a negative 3x. That will give me my negative 3x to the 5th. Negative 3x multiplied by 2 is a negative 6x. We're dealing, so x to the 5ths eliminate. We'd be worried about x to the 4ths, but there's none anywhere to be found, so they're good. They're done. X to the 3rds we already did, so it's negative 2x to the 3rd. I have no x's up here, so 0x, take away a negative 6x. That's a plus 6x. And now I've got, oh, actually I got two terms here. Oh, this is degree 3, this is degree 4, so we're on the remainder here now. So this is the remainder. My 2, I'm going to bring it down. So it's 2, subtract any numbers by themselves. There are none. So that's a plus 2. Which means, just to show you, if I took x to the 4th plus 2, and I multiplied it by x to the 3rd, take away 3x, and then I added the remainder, if I expanded that all out and collected like terms, I would get that right there. All right, so that's what is called long division. Now, there are some types of division where you can use a shortcut. So I'm going to show you that shortcut as well. The shortcut is called synthetic division. Now, synthetic division is used only when you're dividing by x to the 1st. This has to be x to the 1st. So those last few we were doing there that got kind of complicated, the shortcut won't work because we were dividing by like x to the 4th and 2x squared and that kind of thing. So if you're just dividing by x plus or minus a number, you can use what I'm going to show you here called synthetic division. Now the good news is this is really quick and easy, and probably once we get going here with polynomials, we're going to use this like 95% of the time, maybe even more than that. That's the good news. However, you do still have to be able to do long division of polynomials. Okay, so here's how it works. Now the reason they call it synthetic division is because it's basically dividing with just numbers. We don't, so it's kind of like a simplified version where we basically eliminate using the variables at all, provided we still understand how to get the correct answer. So I'm going to take this one And what you do is you take, so you were dividing by x plus 2. You essentially, now you have to include the sign here, so there's no sign showing up. If this was x subtract 2, there'd be a minus 2 here. But because it's x plus 2, it just stays plus 2. But notice the x, it just doesn't get written in there. That's where it gets the name synthetic, because we're just leaving out the variables. These numbers are the coefficients, meaning the numbers in front of, if you remember what you're dividing into. So we were dividing into, and they have to be in descending order, x to the third plus x squared. This was x to the third plus x squared. Take away 3x, take away 1. Well, all right, 1, that's your coefficient. 1, that's your coefficient. Negative 3, negative 3, negative 1, negative 1. So these are the coefficients in, again, descending order. That's important. That's really important, actually. Make sure they're in descending order. And then so we're using here kind of a, so it's not your regular divide sign. It's kind of like an upside down divide sign. There's a bunch of lines and stuff here in this first one just to help you with the pattern. It's a pattern. Like much of math, it's a pattern. You're going to, whatever this number is, you rewrite it down here. So if that was a 5, I'd put a 5 here. If that was a 2, I'd put a 2 here. If that was a 7, I'd put a 7 here. If it was a negative 4, I'd put a negative 4 here. You simply rewrite the first number. Then you multiply this number out in front by that number, and you put the answer up below this one. So it's 2 times 1. The answer would be 2. Now you subtract these. 1, take away 2. So subtract. 1, take away 2, and you put the answer down below here, negative 1. And then you repeat that over and over until you get to the last row. 2 multiplied by negative 1 is negative 1. Subtract. Negative 3, take away a negative 1. So take away a negative, that's plus. That'll be negative 2. 2 multiplied by negative 2, the answer goes up here, it's negative 4, and I subtract these. Negative 1 subtract a negative 4 is a positive 3. Now, just to show you what we just did here, oops, went too far. So we took x squared, x cubed plus x squared, take away 3x, take away 1, and we divided by x plus 2. Now I'm going to do it out long division underneath here. You're going to look and see what happened. X times that, I'd have to go x squared, which would give me x cubed plus 2x squared. Subtract. Negative x squared. Bring down your negative 3x. Negative x squared. Take away 2x, so negative 3x minus a negative 2x would be a negative 1x. Bring down your minus 1. So I get minus, what did I do wrong? X cubed plus x squared minus 3x. Oh, I wrote the wrong number down, that's why. Minus, no I didn't. X plus 2, x cubed plus 2x squared, that's negative x squared, negative 3x squared, negative 2x, negative 1. Something's wrong, either in my synthetic or this. What did I do wrong? Oh yeah, here's my mistake up here. You guys were probably screaming at the screen saying you screwed up. 2 multiplied by negative 1, this should have been minus 2, not minus 1. Now this is going to change these two here. Let me fix this. Sorry about this. Glad I found it though. That'll change this one, and that'll change this one, which is going to give me negative 3 take away a negative 2 is negative 1. 2 times negative 1 is negative 2. Subtract those, and I'll get a 1. So the nice thing about this is I knew what was supposed to happen, and it wasn't happening, so I knew something was wrong. All right, so this one actually was right. This is going to give me negative x, back to blue, minus 2. So when I subtract these, I get a positive 1. Now I want you to look at the answer. So the answer was x squared minus x minus 1. Now look up here when we did synthetic division. Anytime you're dividing just by x to the 1, and you divide into, let's say, x to the 4th, x to the 3, whatever, your answer, this exponent up here, it's always going to start out one exponent lower than this one, because when you multiply your x squared by an x to the 1, this is always going to be one lower, so that when you add these two together, you'll get that exponent, which means that if you're going to use synthetic division, because of this pattern, this is what this, the first, now this one there's only 3, but whatever, the first, however many there are here, they will make up your quotient, and it'll just be the coefficients of the quotient, However, the last one over here, this one is your remainder. Now you have to know this so that when you get to here, you're going to know that this represents x squared, take away 1x, take away 1, with a remainder, remember the last column is always your remainder, so your remainder is equal to 1. Which you can see here when I did the long division. I did it out long division just to show you. That's what I got for an answer. X squared minus x minus 1. X squared, take away x, take away 1, remainder of 1. Okay, so once you see a few of these, I think you'll catch on and say, oh yeah, that's pretty easy to do. All right, so this one is going to go minus 3, upside down divide sign, so make sure these are in order, which they are. So it's 3, negative 2, 1, negative 2, and 4. One thing that you do have to do is, in this method, every exponent place has to be filled. What I mean by that is, let's suppose that this x squared hadn't have been there. Instead of a 1 here, you would have put a 0. So if there's a term missing in the descending list, you must fill its spot in with a 0. So you have to have every power of x accounted for. All right, so here goes with synthetic. So in your notebook, you skip a line. So your quotient's going to go here. Your answer's going to end up down here. Your remainder's going to be over here. We've got to fill in some numbers in between here. The first one, remember, you bring that number straight down. 3. You multiply these and you put the answer there. Subtract. Positive 7. You multiply and you put the answer here. Subtract. 22. Multiply. Negative 66. Subtract. 64. That times that is negative 192. Subtract is going to give me positive 196. This was x to the 4. So remember, this will be 1 degree lower. So it's going to be 3x to the 3rd plus 7x squared plus 22x plus 64. And the remainder would be 196 if you did it out with long division. All right, this one says to use both. We're just going to use synthetic. Now it's going to be minus 3. Make sure these get in order. So it's going to be 2x cubed, so that's going to come first. Then your x squared, which will be minus 3. Then your x, which will be negative 10. And then your number, which is 5. So sometimes students get caught in that one. They just put these numbers without putting them in the right order. They're not going to get the right answer down here. Alrighty. that number, just come straight down. You multiply, put the answer here. Subtract -3, subtract -6, that's 3. Multiply, subtract. Multiply, you get a 3. 5 subtract 3, 2. This tells me that the answer would be 2x. So I was dividing into an x cubed by an x to the 1. So this will be 1 degree lower. 2x squared plus 3x, take away 1, and the remainder would be 2. Okay, one more just to show you we're not going to do long division, we're just going to do synthetic. So I'm going to go 2. Now watch this one. See, it's got no x squared term, so x cubed is 1. There's no x squared term, then a 9, x, and then my 10. So that's important that you fill that 0 in. Students forget that all the time. Bring down your first digit. Multiply. 0 take away 2. -2. 2 times -2 is -4. That's 13. 2 times 13, 26. That's -16. So my answer would be x squared, take away 2x, plus 13, and the remainder would have been a -16 if we've done long division. Now, make sure you didn't miss the key thing that I told you in the beginning. This is great. Students say, oh, I love that. That works really nice. It's fairly easy. The problem is you can only use it when you're dividing by x to the 1, plus or minus a number. Okay, so please don't miss that important detail. And that is what's referred to as synthetic division. So we've gone through and looked at how to divide polynomials, both long division and synthetic division. As I said, this is foreshadowing to factoring polynomials that are beyond using the strategies that you would have done in grade 10 and 11. And that's kind of where we're heading with our next video. All right, so best of luck. Check your notebooks for some practice questions on dividing polynomials. And if you run into any difficulties, bring them with you to class, reach out through email, whatever it is that you need to do to get yourself pointed in the right direction. Thank you.